I'm live. I'm not very good at this stuff. 1 minute, and then I need to share it to coders and cool. We'll see if that works or it doesn't. Oh yeah, I'm totally not ready yet. So if you in and okay. Cool.
Are you sure you're streaming the right screen?
Good question. Yeah, I am. Cool. Well, you could tell me if you went to that link. Cool. Well, I may as well just go. Hello, everybody. So this is the talk I did 2 weeks ago at Gophercon AU, and I did it then in 30 minutes. And the topic is designing Go services for continuous deployment. Sip of water. And I'm going to try and extend it a bit this time so that there's actually time to do a bit of live coding. And by all means, when you see the GitHub repo, if you've got a laptop, by all means clone it to have a play, and we'll see how we go with trying to get people up and running with some of the tasks. But yeah, mileage may vary. So okay, so this is my talk, and I'm at. Come on, wrong thing. Cool. So begin with the premise. So my premise is coming in a minute. This is actually like a replay of the conference talk where I had technical issues and couldn't get. Took me a few minutes to get going then as well. So continuous deployment can improve the design of your code in subtle but remarkable ways. So I don't know if that resonates with you. I think here in Vend, I'm kind of preaching to the masses here because we do CD, and I don't know how many of you have done CD before you joined Vend, and maybe some of you have only really worked at Vend and maybe take it for granted how cool, like how useful this thing is. But so in that sense, maybe it's a chance to just gather those thoughts. Yeah. So I don't know if it's a stretch for any of you to say it's remarkable, but let's test the premise, and I'm going to touch on a lot of topics, and as I say, there's code samples here, so you can explore in your own time if it's too rushed. So first of all, I'm just going to define continuous deployment. For the purpose of this talk, continuous deployment is a release strategy. Any mainline change, by mainline I basically mean a change to your master branch, be it merging a pull request or a push, and if any of those that passes some kind of testing process, could be linting, could be integration tests, and it's any of those changes get automatically released into production, into the hands of users. So my suggestion to people at Gophercon was just imagine doing this with your code, and how do you feel about that? I mean, obviously everyone here does that for most of their code. Maybe some things we don't, but yeah. So I just wanted to suggest that maybe that's a calm and peaceful thought for you. Some people, maybe not. So for some people, if they've never done this before, it might sound super risky, and so when I first came to this, I thought to myself, I'm twitching here. There's some things I'd want to have in place before I go and just allow any change to be put into production. So there's some work culture implications, some caveats, there's work to be done up front. So I'm going to make up a story. So I'm going to use a story to share my own learnings with a bit of an analogy. And obviously it's a story about gophers. This is Geeta, our heroine. She's a gopher, she's an innovator, and she's got a passion for technology and melted cheese. This is her food stall, it's called Toasties Galore, and she makes toasties. So I didn't have to explain this to the Aussies in Australia, but this is a reference to a chain called Barbecues Galore in Australia. So she's starting a business, she's going to beat the competition with advanced cheese technology. And this is the state-of-the-art technology. So she's a hardware freak. She's tech savvy. She's advised us to deploy the software to run this machinery using CD. And so we've got a couple of components here, just two. Chili bin. Again, I don't have to explain this to the Kiwis, but in Australia they call it an esky. So this is where we store the ingredients, and Jaffler is the toasty making machine. That's a reference to a Jaffle iron, which is another Aussie thing. So the Jaffler is the machine that has a basic user interface that Geeta operates to create her toasties automatically, and it's got a mechanical arm. And so the significance of that is that's the interaction between two services. So that's that. So an overview of the software, it's or the code base. It's called Toasties Galore. I don't think there's many repos called that in GitHub. So if you want to try cloning it, you can. It's a mono repo, as in one repository there's multiple services. Two of those are, there's just two services in there, Jaffler and Chilibin, and they interact. There's tests in there, Docker things, Docker Compose, some scripts and some tools, and a basic CI/CD pipeline. So this is the basic architecture diagram. It's just a straight line. Chilibin talks to a Postgres database. Jaffler talks to Chilibin with that mechanical arm, and it's just using HTTP as a transport. So this simple deployment powers 24-hour high-throughput toasting service with some aggressive expectations. Go for speed of binding. So the main thing to note here is the contracts between Jaffler and Chilibin and Postgres. This looks kind of complicated, but this is just my scribble for the CI/CD pipeline. So you get a merge push in. Hopefully it looks pretty similar to what we do here in Vend. And GitHub fires a webhook to Travis, and Travis, on any change, be it master or some branch that's not the mainline change, will verify and build and publish a resource to, in this case, the Docker Hub. And then if it happens to be master, it's going to then, having done all that, deploy to production. So we're using GitHub, Travis, and Docker Hub, but you can substitute any number of alternatives. Right, so this is the pipeline. It's really small. The main thing to note is there's two areas where we're doing something based on some event. So the first one, the script, that's on any change that Travis is alerted to, it's going to run a few things, and then conditionally, if it's master, it's going to run the deploy. So first of all, it's going to run some tests, then it's going to publish. So most of it is pretty sort of plain and not wrapped up in scripts, but these two, because it's a mono repo, and we'll go into that, I've scripted it because there's a bit of smarts it needs to do. Yeah. So, yeah, I'm not gonna, well actually no, let's have a look. getting my full screen and my tab back is going to be interesting. But so when you look at the latest build to master, you'll see that's it, building, running tests. As I say, I feel like for Vend people, this is probably stuff you do every day, but for some people it might be new, particularly if you use a different tool other than Travis. And then there's the deploy there because it's master. So for the non-master branches, you wouldn't see that step. Cool. Yeah, so if you wanted to try that out yourself, I think you can just make a fork and then configure Travis to point to your fork. So, that's not my tab anymore. Give me a second. So, some of you may be thinking, auto deploy is scary. So, say you're on this team and you're worried that you were to release a change and you're worried about the effect it might have. It might break Jaffler. What kind of things should we be worrying ourselves about? So what kind of thing would you think about to protect yourself against failure when some deploy goes out 4 o'clock on a Friday or something like that? Is there anything you can think of that you'd want to put in place?
Deployed in small chunks, having a robust unit test suite, having a robust automated test suite, have a rollback plan if possible. Yes.
Metrics. Cool. So lots of testing and rollback metrics.
Start drinks at 3, no one's going to deploy at 4. So,
Oh, what's that?
start drinks at 3, no one's going to deploy at 4.
Start drinks at 3 o'clock. Love it. Okay. Don't deploy on a Friday. Really? There's been a Twitter storm about that topic recently. So, what kind of things?
Your code should be Friday release ready.
Friday release ready.
Yes.
Yeah, some would say that you can set yourself up so that deploy at any time of day or week should feel safe, which is helpful if you're trying to support a system that has a support issue and you need to deploy in the middle of the night. Cool. So the three categories I thought of: observability, seamless deploys, and integration tests. Not necessarily in that order, but certainly observability, be it metrics or some system to tell you when things have gone bad. I want to hear about it. Integration tests is one type of test, but I think for me that's the type of testing that I've really spent more time on since going to continuous deployment.
Well, because it's API mostly. API integration tests are the most important part. So no one.
Yeah. Sure. So, and seamless deploys, I want to trust that we do a deploy and we don't have to schedule it on a Monday because nobody's using the system, kind of thing. It should just happen, no one's service should be interrupted. So, let's have a look at Jaffler. Next slide. So this is the main function of Jaffler. Hopefully it's short enough to understand quite easily, and I just want to highlight a few things that have happened. First of all, it's just setting up some config through environment variables. TPI is Toasties Programming Interface. It's just a library in the same repo, and then the handler for Jaffler has got a reference to the chili bin. So that is going to be important when we're talking about the integration tests, the relationship between those two services. then this is where we set up one piece of observability tooling. So we're putting some middleware around every request. And then finally, for helping with downtimeless deploys, we've got this thing called graceful shutdown. These are just 3 examples of those areas. There's a lot more to it, but this is just a few examples. So, observability. This is just kind of a quick and easy one. I know we've been looking at recently in Squire. We do this in Vend. So for auth, and I guess for logging and tracing, we have similar middlewares. But basically, what this is, a middleware is the name people tend to use in Go for wrapping up your HTTP handler with some code before it and after it to either track it, authenticate it, cut it off if it's an authentication or auth thing. And in this case, we just want to say, hey, let's observe what happened. So we say the time at the start, and then we record how long it's taken. And hey, why not put in the version as a label so that we can see if a particular version has affected error rates on our service. I don't think that's something we do here at Vend, but it's certainly something we do in places. I know it's something that Honeycomb like doing. Cool. There's other places you might be capturing metrics like scheduled jobs and startup and that kind of thing. Cool. In the repo, there's another one for logging as well. So, seamless deploys. So this is something we might want to quickly try, but I feel like I'm just going to keep going with the flow, and then maybe we could do some kind of short workshop section afterwards. But so this is something, I don't know if you remember, in the main function, just before the end of the main, having started the server on a separate Go routine, we're going to say, we're going to wait for an event. And so this signal notify is just saying, I want to subscribe to a kill or a control C or my platform telling me that it's time to shut down and make way for the next version or just to stop. And when I receive that, it's kind of a polite request. So typically in Kubernetes or ECS, you'll have one of those kind of signals to say, hey, politely, please can you get out of the way and stop processing. So, and then there'll be some timeout before it does a rude kind of destroy, like a kill -9 type of operation. And so in that time frame, we can say, hey, let's, with an appropriate timeout, let's shut down the server in such a way that in-flight requests will still be fulfilled if they take less than 30 seconds, and then as soon as that's done, then it will exit. So we can look at that, doing that in a minute. And that I'm pretty sure we do here. I'm new enough that I can't say for sure, but yeah. What's that? Yeah, we so do. Okay, cool. So integration test. I left this to last because it's kind of the biggest area. So the interaction. So I think typically when you're working on a single service, you might have lots of tests to confirm the behavior of that service with its entry points and exit points, and smaller unit tests. But I think as soon as you get to this level of deployment strategy, then you really want to be thinking hard about how they interact, and if you've made a change to one service, how's it going to affect the other one. So in this case, I've got a separate package for integration tests. So you have the Jaffla package, which is a main package with one service, chili bin, integration tests, and then the libraries. So integration tests is, we saw in the Travis file, there was one line for running unit tests, another one for running this. And so what this is it's going to fire up a Docker Compose environment. Once you get to a bigger scale, then maybe you need something like Kubernetes, something like that. But in this case, it's firing up all our services and then resetting the state to something it can confirm at the beginning. So it's going to say, hey, restock the chili bin, and then it asks it, has it got the right amount of cheese? And then we've got a method under test here, make a toasty, and then confirm that the cheese level has changed. And so the point here is that we've got some setup, we've got an assertion that the state is how we expect it, method under test, and then we're confirming the state. So the Jaffler is the system under test, so it's the interaction we're making is with one component, and we're testing the effect on the other component. It's really that. Cool. So, Toasty to Galore is now highly successful. This was the original image that I had before I colored it in when I did the Gophercon talk. So you've got the Technicolor version of that first image. And also this was like a challenge for Gophercon. How many Gopheroos could you find in all the
So you're
speakers?
saying that you just drew this picture by yourself?
Yeah.
Wow.
Like it?
We have an artist here, please.
Nailed the style.
Yeah.
I didn't notice your coat at all, but that's
Yeah. Yeah, well, before I added the story, it was a pretty dry talk, so I'm glad you like that part. Introduce conflict. But then some gophers aren't happy. We're super busy, some orders are going to the wrong gophers. Gwenda got pineapple instead of Vegemite, and Gary received cheese instead of soy cheese, which is not good. So, we've got design problems. What do we do? Thankfully, Gita's a fast decision maker, and she says all we really need to do is to track orders with customer names. And then it goes to the team, and we've realized that our API design is a bit yucky. We've done it as a get this request to restock or pick stock from chili bin, and it really ought to be a post so that we can enrich the requests with more data, and also it feels pretty bad to be using a get. It's a design flaw. So we want to change that contract. So we want to add some data to it. We want to change it to a post. Okay? So it's a breaking change. And then behind the scenes, as well as updating the ingredients beforehand, it's going to insert an order with a name against it. Cool. Breaking changes. API signature needs to change, DB structure needs to change. Morty is scared. Has anyone seen the new episode yet? No? Security guy has ways. Us. Oh my god, this is scary. But Gita has a solution. She says, let's dance. So I picked the first name of a dance I could find in Google that was a 3-step dance. So it's a foxtrot, and the idea being that we're going to break up our release, similar to what Kate was saying, small chunks. But specifically, first we add the new implementation in a way that the Jaffler isn't going to call it yet. We're going to migrate comfortably, maybe with feature flags, something like that, and then we're going to delete the old implementation. Cool. So, 3 steps. Once you've got CD, it's easy. Why not just line them up? Just create 3 pull requests. First one, implement. Second one, put in a way to conditionally call that new endpoint. And third one, important, easy to forget, but important, and so why not line it up? Delete the old endpoint. So, step 1. We've got pull request there. serve the new approach under a different URL. So there's two URLs side by side, and now there's two versions of that. So crucially, V2 can be tested manually but isn't invoked by any other service yet, and the calling service hasn't changed. So let's look at that PR quickly. We've got a bit of refactoring going on, and we've extracted this update statement into a method called doPick, and then we've got this pick v2, a new method, and a request object because we're receiving a post and want to unmask it. Unmask it, decode it. Then we're going to do an additional insert into orders, and again call that in a method. They both call the same method, and we'll put it inside a transaction. There's the doPick, which is just moving some code over. Straightforward so far, I hope. Now, database migrations, everybody's favorite. So I'll come back to that, and then we're going to add a test so that at least something is, even though Jaffa isn't calling it, something is calling this new endpoint and confirming that it behaves how we intended. Cool. Step 2, invoke new implementation. So this is something we're really good at Vend, and I picked that up at Gophercon, you'll be pleased to hear. But this is like a really simple implementation of a feature flag. So you can minimize the impact of this change and initially focus on Gita herself, so she's not going to mind if something goes wrong with her toasty because it doesn't affect the customer experience, and then you can gradually extend that out. So in some cases this could be backed by a service, by a DB table, by configuration, and there's lots more weird and wonderful things you can do here which we know very well in Vend. Does that all make sense so far? I think it's all pretty natural to us here. Cool. And then finally, delete the old implementation. Do it soon. Line it up in advance. Plan for it, otherwise you'll forget. That one I'm not going to bother. And also easy to fear. Things can go wrong with that, but it's so important for feeling like this is something you can do really regularly. If you do it regularly and your code base becomes bigger and more bloated and full of stuff that you don't know if it's in use anymore, then you're not going to want to keep doing this very often. So I'm just going to quickly go back to step 2 just to show you what that was. We're updating our integration tests so that calls v2, and then we're creating an additional method on the client which Jaffa uses to call pick v2, and then we've got that has feature invocation. All right. Cool. So, my conclusions from that. When deployment is a non-event, you can make your releases safer, your code remains cleaner, and when you have more viable options within easy reach, you're empowered to make better decisions. So, that's the end of the story part. And then following that, I've just got some tips and tricks that I've picked up along the way, mainly not from Vend, mainly from my time in previous companies, where, for example, using mono repos and other slightly different circumstances. So, on configuration. So what I found is, having embraced this kind of methodology and having had these apps with big config files, it's like you don't really need it anymore because your code can be updated and pushed to production just as quickly as a config change. So that felt like quite a big simplification. Didn't need to do so much wiring. Stuff became more readable. So Yeah, so as I already said, deployment's fast, just edit code or artifact or put a file in with your deploy. So M variables, 12-factor apps, I don't know if you're familiar with that doc, but it's nice and easy to work with. I'd love to hear what Alexei thinks about all this. Is it all sounding pretty similar to what we do in DX? Is what I'm describing quite similar to what we do in DX? Good. Cool. And use constants. Like if you have a magic number for something, you might be tempted to kind of wire it through your function calls, whereas here you can just pop in a constant, and if you need to change it, just push a change. Monorepos. So monorepos are quite an interesting adventure. In some cases, they make life much easier. Other cases, more complicated. So in terms of CD, easy to main pipeline centrally. So you can have one sort of pipeline generator or one pipeline that triggers on the whole repo and then decides what needs to be built. And as opposed to when you have lots of repos spread out, if you want to make a change, you can make it in one place, which is useful. And then in-house dependencies, like your libraries, they're all local to the repo, and so upgrading is easier, and testing combinations of components, it's just all in one place, so it's easier. But challenges: identifying what to build, test, and deploy on each commit. I can show you an example of how you might want to deal with that in Go, and speed becomes an issue every time you want to deploy or make a change to a big repo. Then it needs to understand a much bigger piece of software. And third-party dependencies. So the way you do Go mod or Go dep can be a bit challenging to have that work at a top level. I've got an example of how you do that and get Docker and Docker Compose all working in that repo. I don't know if we'll have time for that one, but it can be tricksy. So in a monorepo, do we really want to deploy everything on every change? Not really. Brendan doesn't want to. I don't want to really. And how can we filter that? Filter which services need to be deployed on a particular change. And my answer is it depends on the language and what tooling is available, how you achieve that. It's probably achievable in most technologies, but in Go, the way I've worked with it before is a bit like this. So we've got two scripts in there which we saw earlier, publish.sh and deploy.sh. And this is run by Travis every time. So this is published, so it's run on every build. And so for every service in our repo, it's going to find what is the last commit that affected that service. And then it's going to use that commit hash as a tag on the artifact. So what that means is if you make a change that affects the shared library, it should force a redeploy of all the services that depend on it. If you have one that only affects Jaffla and not Chili Bin, then the tag for the hash for that one will change. We'll redeploy that one. The other one, it'll already be there. We won't do anything. So it's asking Docker Hub, hey, does this commit already exist? If it does, it doesn't need to do anything. So that calculation, which is the Go specific thing, is Go list minus steps and some filthy grepping and setting. Ignore that bit. But there may well be other more polished ways of doing this, but Go list is your friend. It finds transitive dependencies, and then you can pass that to Git and say, hey, given these directories and files, when was the last time they were affected? Cool. Does that make sense? I think in Monocle we have that kind of problem, or that kind of concern. I don't know if we've solved that yet for Monocle. That's for front end. So deploy any affected services. Cool. DB migrations. This has always been a bugbear wherever I've worked. So some of the challenges that come up, you want to make a change that affects a big table. It might be long running. If you were to run that as part of a deploy, it might cause the deploy to be like badly delayed and could cause some other unexpected behavior, and also rollbacks become awkward. So my 3 tips I've got up there: use transactions. So if you're using Postgres, you have transactional DDL, so you can do an alter table and things. And what that means is you can start transaction, run this code, run these statements in advance. If there's any conflicts on unique keys or something like that, you'll know beforehand, before it gets to your production database, that it's might be a bad idea, or at least you might want to rethink it. There's different ways in different SQL dialects to make these statements idempotent. So if not exists, kind of exists in different databases, and split them up. Create table is cheap. Trickier stuff might be affecting those big tables in tricksy ways. So splitting them up kind of helps. I've found in different places I've worked, some places there's a strong culture of it must go out exactly the same time as the code because of breaking changes. Other places there's a lot of trepidation around running it as part of the deploy. I don't think anyone really wants to talk about that anymore. Cool. So this is just the mechanics of running with this tool I've used in the past. I know we use Goose here, but this is using one called Go Migrate, and bundling the migrations in the Docker container. So it's pretty straightforward to use. And then I kind of scrolled straight past it, but the migrations we were looking at had a transaction around them. And this is something you can run in your main, or you could just have a separate way of running it. That's one way we handle that in Vend. I believe you have a different command line argument to run your migrations. Cool. So another shout out to Vend. On DIY tooling, Vend, we have a Slack bot which offers a number of CD related utilities. There's other ways to invoke those utilities, but Slackbot is pretty convenient. Canary deploys, rollbacks, feature flagging, service status. Cool. On CI/CD software, I've tried heaps. They all work. Lots of people get angry and frustrated with different ones, but I'd say just pick one. Cool. So conclusions. How will it change my code? More than anything else, CD affects how you change your code. My conclusion. Forces you to deal with important things up front. Most of these have their own payoff, so it gets you into a good place. Encourages good practice and enables safe and easy changes. And the impact, I believe, it's a bit indirect, but your code ends up simpler with fewer contraptions, fewer cobwebby corners. Your appetite for tidying things up becomes more comfortable, and change is simpler, meaning resulting in you have better options. I do feel like whenever you make a change to a piece of code, how easy it is to make that change really factors into what decision you make. So more easy decisions tends to be good. One or two pieces of advice: it's hard to retrofit. Like, it's so good. Like, I asked Nick the other week, when did the CD thing start here? Maybe someone else has an answer for it, but Nick was like, it's just always been here. So I think we don't know how lucky we are. This talk began with loads of rationale about why you should do this. I ended up just cutting it out because of time. That website is one example of a place you can go to find. There's loads of research done on why this stuff is beneficial for your organization. So if you ever need to convince someone, a team member or management, why this is good, you can look up some research. It'll tell you about reduced risk, faster time to market, high quality, better products, and happier teams. So have a play with Toasties Galore, and maybe it will help you. So that's all. Apart from maybe we could do some practical stuff if anyone would like. Cool. So would anyone, well, first of all, any questions? No questions? Wow.
Well, probably I think there will be more questions if we could really play our hands on it.
Yeah, so if you want, I mean, it was booked for an hour, we got 15 minutes or so, we could have a play with a couple of bits. Anyone want to try?
Break it.
Yeah. Want to do that? Cool. So, I'll share the repo with you on Coders or something, and we can give it a go. Thank you. So, I mean, one thing I could start with that's quite quick to just play with, if you've never done the graceful shutdown, we could just see it in action if you like. So we could start up some services and all that. So, I'm just gonna change something here. Cool. So I think I've still got some of this running from last night when I was just checking it was still all working, and it wasn't, so I'm glad I checked. So we've got some make files, some Docker Compose stuff in here, which hopefully is all familiar to everyone here, but so let's do make. Is that big enough? I'm not hearing a no, so I'm going to say yeah. Yeah? Okay, so let's. So I don't know if any of you has tried cloning this already and wants to try it out. It might be a little bit incomplete. We might need to run a couple of Docker Compose things. So do shout if you try this, it's not working. So make start Postgres, and then so you can run all this inside of Docker, or you, for the purposes of this thing, we're just going to make. Let's go into Jaffler. Thank you, OSX. And then I'm going to run, oops, Chilibin, run that. Cool. So let's do some curling. So first of all, I'm going to ask Chilibin what's in stock. So it's just got some JSON payloads. That might be a bit small. I'm going to make it bigger. So I'm curling to Chilibin, which is where the ingredients are, to say how much you got. So I want to restock. And then I want to go to port 7000, which is Jaffler, which is the outer one for making the toasties, and I want to send it create a toasty. So it comes back pretty quick. But what we can also do is we can make it slow. So we can do doneness equals burnt. Cool. So it's going to take 10 seconds. See, this is the good stuff which people at Gophercon never saw. So it's burnt. So we're going to go to Jaffler. I'm going to cancel it, and it says received OS interrupt. It's going to still take the 10 seconds before it dies. Yeah? Did you see that? Cool. That's it really. So when I first tried using this, the standard library didn't have it. There was something called Facebook Go or something which had a way to achieve this, and I was deploying to virtual machines, so we were swapping out apps on the same machine, so it was really important to get this right. It's still important to do it in Docker, but it doesn't have to make way in terms of the port allocation in the same way, but it's still good to not interrupt those requests. Cool. Does anyone want to see, what else would anyone like to see? Let's see how Travis builds, or should we try and break the build? Break the build. Yeah, let's break it. Cool. So we could break the contract, or good point. Test that's never failed isn't worth its salt, right? Yeah, what should we do? Should we go into the handler and send something bad to Chili Bin? See, this was nearly a very different talk. I was ready for loads of example stuff, but yeah. Cool. Cool. Let's push it up and see what Travis does. Up into cool. I guess for most people here this is all pretty familiar, so I guess I'm not really showing anything new. So maybe we can see that hopefully it only tries to, oh no, it's going to break before it tries to conditionally build something. Test run and everything, so. Silence. So I think the whole thing runs in about a minute and a half, but yeah, cool. That's awesome. That's not awesome. So.
What does this make any money?
So the only optimization I put into this so far was just to render the dependencies. It was having to pull them down 3 times each time. I haven't tried using any Travis caching features. I don't know if anyone else here has, but that would make it faster. Yay, it failed. Did it fail? It keeps going. That's not good. Oh yeah, that's right. It so in Travis you have all those tasks, and if one fails, it doesn't stop the other one from being run. I guess it means you can get feedback about all those things unless you do something. There's a special Travis shell command you can run.
Have you tried that command? Is that documented?
Yeah. It's called. I can't remember what it's called, but it's. I can find it. That's it. Travis _ terminate. There you go. Cool. Was there anything unexpected that I showed you today that you wanted to talk about, or shall we wrap it up? Yeah. Yeah, right. So the part of, I think I get the question. So you're asking, is it necessary to stop listening on the port? Yeah, so it's not, that part isn't necessary for how we work, where it doesn't need to give up the port. The main thing is, yeah, I guess the whole thing could be left to run until the 30 seconds, but one advantage of doing this is that it will tidy up, it will shut down sooner, so it won't have to wait the 30 seconds. In a lot of cases it will just wait 1 or 2 seconds, so it will speed up the pod.
There's one case as well, if you're running something like mod, and it can actually keep the process open on your development machine. So if you're doing like a firewatch or restarting the server, then Grace will shut down and keep it open.
Could get orphan. So you're saying that's
Good.
That's good.
Because this is a tool that I use for building Go, and sometimes it can open a web server at the city and the process it before building stuff. So the Grace will shut down.
Doesn't. Oh, okay.
For services that get called, like a web service, it's maybe not that important, but for services that pick up their own work, like a background worker or application or something, they'll keep doing their stuff until they're getting shot in the head, right? For those scenarios, it's important to ask them to shut down first.
Yeah, true.
We had a situation like that in payment service for a while because there was this long running API call that we had to make up, so we ended up doing a separate build team. But occasionally, if we deployed a new version of the service, or if things just got shuffled around in ECS, then that API call would get interrupted and bad things would happen. So
So which one was that?
it was in Swiper, the payment service, because one of our payment integrators has this stupid API that runs synchronous requests. So it's like you start the payment and you have to keep the connection open the entire time that the payment is happening. So like one person is pulling the credit card out of their wallet, swiping it on the machine, like that whole thing. So we had to put a really long time on it.
Yeah.
That was the request that they were
Right. Yeah. figures. Yeah. So, Nick, I'm thinking again. I think probably if we don't implement a graceful shutdown, then Amazon is just going to kill it. It's going to send the gentle kill, and it's just going to go, okay, I'm done. And then any requests that are in flight will just get a 502 or something by gateway. So, yeah.
The first attempt is secure.
Yeah.
Then if this process, like if the process does not respond, now this is secure.
Yeah.
Secure cannot be cut. You cannot add placements.
Yeah. You're gone.
Yeah.
You're toast. You're toast. Cool. I think we're coming up to 3 o'clock on the dot, eh?
Yeah.
Thank you.